So we are on live on YouTube also. So welcome everyone. I hope Kalmar people can listen to me and also see the slides. But if you don't, let me know on the chat or maybe on the Slack. And as I understand, there are many students that I was expecting from different programs, but maybe people will show up slowly. And I guess you also had another lecture with Tobias on requirements, right? I think a few days ago. And you will have similar lecture in Kalmar, also by Tobias. But for my lecture, I will go into further details about requirements, elicitation, validation, and management. But instead of having two lectures, one in Kalmar and one in Växjö, I thought maybe it's better to have one lecture here because most of the students are here, and also live stream on YouTube. Probably that's why we are missing some of the people who wanted to also follow on YouTube. Other than that, this is part of this introductory project course, 1DT through 308 and 1DT 902. And if you remember, we have 3 goals. So one of them is about requirements. That is the first requirement, the first goal, basically, A1, that I will cover in this lecture. And feel free to ask any questions. So make it more interactive if you would like to join in the discussion, or if you have any questions in mind, feel free to ask. Let me see if people in Kalmar can see my slides because they did not tell anything. Okay. So the parts of the lecture are from this book. There are several chapters on requirements, and they describe what are the good practices to manage requirements or to handle requirements. And the lectures I am giving here is also part of, I think it's not in the center, the display. It's also part of another course. So I am trying to covering some of the topics that I provide in another lecture, in another course. And in this lecture, we will cover about requirements. So what do we mean by requirements, and what do we mean by requirements engineering in particular. And then we will talk about requirements document, elicitation, how we can analyze requirements or negotiate, how we can validate requirements, and finally the requirements management. That is also one of the critical part of requirements engineering. So first thing first, what are requirements? We already know, perhaps, from the previous discussions and also from your previous knowledge and experience, that requirements are not only what the system should do, but also how the system should behave. But these are more informal definition or informal conceptualization of requirements. Usually we define requirements in the early stage of the software development, but this might not be always the case. In particular, if you are following agile development principles, or if you are doing the lean programming, you may not always define your requirements in the beginning, and you incrementally define or modify or refine your requirements. But requirements describe many aspects in the software project. So it's not only about software, it's not only about the product, it's also about the users, the people involved in the product development or in the product use. So the requirements describe, of course, the user level facility, that is the functionalities. Then what will be the characteristics of a good system? So, or in other words, how the system should behave in a manner that we want. And then specific constraints. So let's say those are not functional requirements, not non-functional requirements, rather some extra constraints or some optional constraints, let's say. And then also, when we are developing the system, once we have the requirements, we might have some development constraints also. So for example, what platform we want to use, what language we want to use, and so on. But these are the definitions or the ideas, as I mentioned. These are more general concepts, or how people define them. But there is a very standard definition of requirements provided by IEEE. So I believe all of you know already what is IEEE. And they have a dictionary for computer science, or in particular software engineering, where they defined thousands of concepts and that are particularly about software development or software engineering. They defined requirements very specifically and very precisely. Is that requirements are conditions or capabilities needed by a user to solve a problem so that they can achieve an objective or they can meet an objective. So requirements are somehow descriptions of objectives. And then requirements are also conditions or capabilities that we want, but following some standards or some contracts or some guidelines or specifications, because you cannot write anything you want as your requirements. Your requirements should conform to some standards or to some contracts. So let's say the contract can be between the end user and the developer, or the customer and developer, and so on. But having these requirements in your mind is not enough, and that's why the definition provided by IEEE added also this third aspect of the requirements. So those requirements should be documented. So without documentation not by, I mean not the description, but you have to write it down or specify your requirements in a formal way or in a more structured way. So without documentation or without a written requirements, those are not considered as requirements. So that's the third point, that it defines that the condition or the capabilities of a product or a system should be documented well. I forgot to mention one thing. So I have around like 90 minutes or maybe 80 minutes of lecture. So you want to break in between, or you want to continue and finish early? It's up to you. So any ideas? Sorry? Finish early. Okay, then I continue, and if you are bored, let me know. We can have fun. So we are talking about requirements, but requirements engineering is another concept that basically deals with the requirements, but in an engineering fashion. And when we call something engineering, so we know software engineering, civil engineering, mechanical engineering, and so forth. So when we call something to be engineered, it has to be systematic, it has to be repeatable, and also the product or the end product should be complete, consistent, and relevant. And let's say we are building a bridge. If we have a design of a bridge, if we build 100 times of the same bridge with the same design, it will result in the same, like structurally the same bridge, right? You cannot have multiple bridges with the same design or with the same specification of the bridge. So that's why this engineering term is also relevant and important in requirements. And it involves not only specifying requirements, but you have other preconditions, like you have to discover all the possible requirements, you have to document them, and requirements might change, or they will change definitely. So over the time, you have to maintain those requirements as well. But there is a problem, sorry, not problem, there is a difference also, requirements for the computer-based system and requirements for, let's say, business requirements. So anybody has any input? What can be the potential difference between business requirements, let's say, and software requirements? you can say anything you like. I mean, of course, people will not complain. Yeah.
Business requirements. Maybe so they want 20% more of sales, and maybe software.
Yeah, this can be one difference. One difference, and one difference from the objective or goals perspective. Like we want to make more profit, but when we are talking about requirements, uh, so software requirements are negotiable. You might want to include or not want to include all the requirements, because without some requirements your system or your product will still run, but business requirements are not negotiable. So whatever objectives or goals you have in mind before starting your business, you have to fulfill them if you want to sustain your business. But even with one functional requirements or one requirements that you mentioned in the beginning of the development of your software, it will run, or it will be a viable product. That's the main difference basically. In the waterfall model, we already know this old plain waterfall model for software development that people don't follow these days. Requirements engineering is usually done in the early phase of the development process, but there are other approaches, as I mentioned, agile. There are many agile processes, but for example, lean programming or rational unified process, RUP, they continuously evolve and redefine and define requirements until you deliver your product. Even if you deliver your product, your requirements might change based on the customer feedback. So requirements are never stable basically, or never fixed. So we talked about requirements, we talked about requirements engineering, and then we also mentioned, according to the IEEE definition, that requirements must be documented. If they are not documented, they are not considered as officially as requirements. So there is a document called requirements document that almost all the companies they maintain. So if you don't have this document, it's very easy to develop a scrap or develop a garbage system. So requirements document is an official statement of the system requirements, and this should be developed in collaboration with your customers, end users, basically all the stakeholders. So all the stakeholders has input on this requirements document. There are various names. People might use different names like software requirements specification, SRS. This is also a very common name, but end of the day, what it contains is basically details of your requirements. You already learned types of requirements from the previous lecture, but I think there are other perspectives if you want to define or identify types of requirements. One is based on the level of details. So usually requirements come from the end users, but end users are not or might not be technically sound. So their requirements are always in high level and maybe using natural language that is easy to understand, but they might have some technical deficiencies in the specification. So these are the two kinds of requirements. If we consider the level of details, one is the user requirements or stakeholder requirements, and then the system requirements. So the system requirements are more at the technical level and more detailed. You can use many different notations, including mathematical notations, graphical diagrams, like, for example, the UML model. So those are also those can be also used to explain or specify your requirements. But then there is another types of requirements that we all know, that is based on the goals. So what type of goals we are achieving using these requirements? So it can be a functional goal or it can be a non-functional goal. And the idea here is that the non-functional goal requirements or goals, they are often decomposed in terms of functional requirements and some constraints. So I will give an example here. So let's say we have a requirements that non-functional requirements that says the authentication process should be completed in 10 seconds or less. So as you can easily see, here are multiple parts. Of course, the authentication process, that is the functional requirements. So we should have authentication functionality. And then the authentication should be completed. That means it should be successful. If it's unsuccessful, then the requirements, both the functional and non-functional, are not met. And then you also have a constraint. So it should be completed in 10 seconds or less. So ideally, the non-functional requirements are the combination of functional requirements and constraints. So this might not be in our minds from the beginning, but this is the fact. And when you are writing your requirements, you should consider, or you should mind that your requirements statement has both the functional requirements and the constraints. If it's not there, it could be the case that your requirements are not complete. So we come to that this part more, how to validate or how to analyze requirements later. Now, the stakeholders. Since the beginning, I mentioned stakeholders are the source of all requirements. So if we consider end users as the stakeholders, or the customers of the system, even the managers, developers, tester, whatnot, they're all stakeholders of your system. And stakeholders are those people that are directly or indirectly affected or influenced by your system. Now, here is a simple exercise. I know many of you are developing IoT-based projects, small scale, of course. Let's say we want to develop a IoT-based notification system for railway. And using this system, we have different rail crossings, right? So the authority wants to automatically identify objects on the rail crossing if, let's say, there is a train coming and in 5 minutes or in 2 minutes, and we want to get notified that there is an object at this rail crossing. Please take actions or whatever to remove that object, or to make sure that the train passes safely. So if we consider this scenario or a system, who are the possible stakeholders that could be in your mind? So let's say we are developing this system and we want to discover or find out requirements. So which are the people that you will go and ask their needs or what they want? So give me at least 4 or 5 stakeholders. Or there is no stakeholders? Of course, as a product developer or designer, you are one of the stakeholders. So you know some of the requirements, but you might not know all the requirements. So who are the other stakeholders? Yeah.
Perhaps the ones who are driving the locomotives.
Sorry.
The drivers of the locomotives.
Yeah, I mean, or the train here in this case. Yeah, the operators or drivers. This is one, definitely, yes, because they also need to be notified, and they might have requirements how they want to be notified. Any other? No? Okay. So there can be a long list of stakeholders. I think that's why you don't want to give me a long list. But some of them, as you mentioned, are operators responsible for running the train or the signaling system. The railway managers, because they are the manager of the operators or the train crews. The passengers, of course. The equipment installation and maintenance engineers, The safety certification authorities. This is also critical because every software nowadays have security and safety issues, or at least the end users or the customers, they're highly concerned about this. And in particular, when you are going to deploy your solution at a rail crossing, let's say, there must be some safety guidelines that you have to ensure. So the safety certification authorities will inspect or look at your product and or your deployment and certify your product. So they are also part of this project or this development effort. So system stakeholders basically can be a long list of participants or interested parties, and you should talk to all of them to find out their requirements. And if you don't, you might be missing some critical requirements as well. And so we talked about requirements, we talked about requirements engineering, requirements document. And then what the question is, what is the requirements engineering process? So requirements engineering, we mentioned it's about discovering and then analyzing and managing your requirements. But all these activities or process should be done in a structured way or in an organized way. And if you do something, it can be anything. If you do something in an organized or structured way, it becomes a process. And a process is always repeatable. So whatever product you develop or whatever system you develop, if you follow that well-defined and well-structured process, your product or your system will be a high quality and more complete product. So that's why following a requirements engineering process is very important in the domain of requirements engineering, and also when you are dealing with requirements. Then a complete process should have this following properties or following segments. So basically in the process, it should be defined what are the activities that we are going to carry out, like of course development, testing, then designing and so on. And then the structure and schedule or the timeline of these different processes or different activities. And then who is responsible for each of the activities, the input and output for each of the activities. So you may define different artifacts or different outcomes of your different steps or activities. So you have to define both the input and the output for each of the activities in your software engineering requirements engineering process. And then what are the tools that you are going to use? So if you do not use the define the tools, obviously all the organizations have their standard tools. If you do not define the tools well in advance, when you are developing the product or let's say testing the product, you are basically lost without a clear guideline. And these guidelines should be part of your requirements engineering process, and that is defined in your requirements document also. So although very few organizations explicitly follow and define standardized requirements engineering process, they mostly focus on requirements document. So even this recent agile methodologies or lean programming, they do not follow a well structured process. All they want is to develop and deliver the requirements based on the requirements document. So this is an interesting view, a spiral view of requirements engineering process. So as you can see, it has three aspects. One is the requirements specification, one is the requirements validation, and one is the requirements elicitation. So these all three are part of the requirements engineering process. But then for the requirements specification, let's start with elicitation, because we are gathering the requirements here. So for the requirements elicitation, we have two types of requirements. So one is the user requirements and one is the system requirements. So we elicit both these two types of requirements. For the specification, we have business requirements. So that's the high level business goals, let's say. We have user requirements based on these business requirements. And then finally, we have system requirements, specification, and modeling. So the more higher you go, the more detailed it is. And more lower you go, more easy to understand it is for general people or non-technical people. And then you also have requirements validation. You have multiple ways of validating your requirements. So you can do a feasibility study based on your business requirements, that if it's feasible to make profits, given that I have this asset or this investment and so on. Then you also have prototyping. So once you have requirements, you might validate your requirements using different techniques. I will come to that point also later. And then you also have reviews. So you have to review your requirements to validate them. And now if I want to follow the spiral, so if I start from here, so I define my business requirements here. And then in the validation phase, I do the feasibility study to validate these business requirements. In the elicitation phase, once I find that our business goals or business requirements are feasible, we collect the user requirements. And once we have the user requirements, we specify them using some structured template. So that's why it's called specification. And then once we have well-defined and specified requirements, we go for prototyping. That means we either build small-scale simple system, or we prototype, let's say, even using a paper by drawing interfaces. And once we build a prototype, now we know what are the system requirements. So in which system they will run, in what type of servers they will run, what type of memory, what type of processor, and so on, what type of operating system you want, and all these things. So you combine these system requirements and user requirements, and you find or you go do the system level specification and modeling. And once you have this, you have close to a complete requirements document. But to finalize or seal the document, you have to basically do the review with the experts and all the stakeholders as part of the requirements validation. And then basically at the end, you come up with this requirements document. So any questions on this complex spiral view of the process? I think it's also easy to understand, but if you look at it more, you find more perspectives also. But talking about requirements engineering process, what is a good requirements engineering process? The answer is there is no one single good requirements engineering process. It depends on the organization, their standards, their practices. But unfortunately, most of the standards, including the IEEE standard, they do not focus on a software engineering process or defining a software engineering process. Rather, they focus more on the requirements document itself. So how should the requirements document be structured, or how it should be built, and so on. And this is the first document ever, US Department of Defense standard 2167A. So this is also a standard document for managing and writing requirements, but it's more from the development of military-based systems. So they also did not focus much about requirements engineering process, rather more about requirements document. And a good requirements engineering process will focus on these three aspects that we also showed in the previous slide: requirements elicitation, requirements analysis and negotiation, and requirements validation. We will come to these three activities later in the following slides. So that was about requirements and requirements engineering, and I think I took more than I expected. But if I feel that I'm taking more time, probably I will skip some of the slides that are not very interesting for you. But I will put the slides, of course, on the, I think there is a page on my Moodle. So I will put that these slides on the my Moodle so that you can have a look at the later time. So requirements document, we already mentioned, this is the official document for specifying your requirements, both at the high level and also at the detailed level. There are various names people use. Software requirements specification, or SRS, is one of the most common ones. And a requirements document is considered a good quality if it has some certain attributes. So you cannot write long paragraphs, you cannot write requirements in an inconsistent language that is not easy to understand for all the stakeholders. Rather, you should have a clear and consistent specification that is easily understandable by both technical and non-technical people. You should be concise, so you don't need to write many paragraphs to define or describe a requirements. And also your requirements document should be written in a way that is easy to change, because if you have a 50 pages of requirements document and your readers or people who are maintaining your system, they get lost to find out certain requirements or to find out information on certain requirements, that means your requirements document are not well structured and it's not easy to change. So these are the good quality for a requirements document. But again, there is also a standard that is defined for defining or for writing your requirements document, but people do not always follow such standards, and it might vary according to the custom or practice of your project or of your organization. But the end goal is, again, so that readers can easily find your information. And then when the reviewers are reviewing your document, they also don't get lost, because we also saw that as part of the requirements validation, the last step is to review your requirements document in the spiral view here. So here we are reviewing our requirements document based on this requirements specification and modeling. So if the reviewers are lost here in this step, that means your requirements document are not well written. So what you have to do, basically, you have to go back all the way where the problem started to fix this issue. Then, yes, and one of the most common standard is this IEEE 8301993 standard. So as you notice, is defined in 1993. That's a pretty old standard. And also there is no single standard, as I mentioned. So organizations might follow their own format that has been doing fine for them. But the IEEE 8301993 standard looks like this. So you have a standard introduction, so where you basically describe high level in high level language your purpose of this document. Then you might define different acronyms. You might provide references to the external sources. Then in the second section, you provide more general description of the product. So what product you are going to develop, if you have any constraints and so on. And of course, that is also most important, assumptions and dependencies, because if you have wrong assumptions for your project, you will end up having wrong requirements also. The critical part is, or the core part is the section 3, where you basically define all the functional, non-functional requirements and also external interfaces that you are going to use. and the appendix and the index. So this is although this is a standard guideline for defining a requirements document, but you can deviate from this guideline based on your needs, or if you want to follow a different structure. But regardless of the guidelines or regardless of the organization, each requirements document should or must have these 7 elements to make it more complete documents. So one is the overview of the system. This is basically part of this section 2. Then the glossary explaining the technical terms, that is part of your section 1. So you if you have a reader, in particular non-technical reader, they might not understand all the technical terms, so it's better to define as early as possible in the requirements document. Then the definition of functional and non-functional requirements, constraints, those are extra or optional constraints. The operating environment, so where or in which operating environment your system will be deployed or run. And then finally, the detailed system specification. So basically, for these 3 and 4, you might model, or you might have some preliminary visualization of your design based on let's say either UML model, data flow diagram, and flow, and so on. So we have the requirements document, and we also mentioned that there are various stakeholders, and basically those stakeholders are the users or target audience for your requirements document. So obviously the customers, system customers, then the managers, because based on your requirements document, the managers will plan the budget and time and so on. The system engineers who will, or the developers who will develop the system. The system maintenance engineer, so once you deploy your system, once you developed your system, who will take care of the system for its remaining lifetime, and if there is any changes, they will go back to your requirements document, and they make sure that the changes in requirements documents are reflected in the product, and also vice versa. Then the system test engineers, so they will define or develop test cases for your system, so they also need to understand well your requirements document. And of course there are other stakeholders, and they might have different interests in your requirements document. So requirements elicitation, although that's one of the very first step for your requirements engineering, I introduced it a bit later. And requirements elicitation basically is all about discovering your requirements, but being a stakeholder, I cannot express whatever I need. To express what I need as a requirements, I might or I must need some application domain knowledge, and also the organizational knowledge. So organizational knowledge means the organization I'm working for, and because also different organizations might have different requirements. So without these 2 knowledges, if I express a requirements, they might not be consistent, or it might have some problems. So to elicit requirements, one must understand the problem, what we are solving, the business process in the organization I am working for, or the ways the system will be used, or in what condition the system will be used. So we talked about stakeholders, but the question is how we can identify stakeholders, because before identifying the requirements, we need to identify stakeholders first, and then we go to the stakeholders to identify their needs. So this is also one of the important steps to identify your stakeholders right or correct. because if you do not have proper list of stakeholders, or if you miss to identify some of the stakeholders, it's likely that you will miss also some of the requirements that could be critical. And also, if you have more stakeholders, you will have different viewpoints, and if you talk to all the stakeholders, it makes them feel that they are part of this development effort. So inclusion is also an important thing here. So how to identify the stakeholders? Again, all this the 5 target audience that I mentioned for requirements document, basically those are stakeholders. So end users try to consult the business processes that is part of the organization, because people involved these processes, they might also have their own requirements. Then the discussion with the management, so managers are also part of your requirements, the customers, and also people who are developing or maintaining your requirements. And of course, the external bodies like certification agencies or safety agencies and so on. But when you are, so once you have the stakeholders, the next step is to elicit the requirements, right? And the best way to elicit requirements is use the system as if you have developed the system already. So to have, I have, I think, next few slides talking about how we can analyze and gather or even refine our requirements. But one of the way is to gather requirements is basically describing or discussing the scenario or stories of the system with the end user. So the end user might interact with the system, and you can gather more functional and non-functional requirements based on their interactions or based on their reactions. And some of the aspect that will help you gathering requirements and the information based on which you will gather your information is basically the state of the system before the interaction starts, the flow of the events, the exceptions to the normal flow, the description of the system after the interaction is done. So this is these scenarios or stories, this can be gathered or done, either use a prototype system that is a minimum viable product, or it can be done based on just drawing your interfaces on the paper and showing it with to the users or end users. So we will talk about more this in the requirements validation part. But once we have identified the requirements in the elicitation phase, our next goal is basically analyze them or negotiate requirements. And this how it looks when we are analyzing the requirements or negotiating the requirements. So this is also a process. So we start with the domain understanding. So as we mentioned, that we need domain knowledge and also organizational knowledge. So once we have this domain understanding, we go for requirements collection. And if our requirements collection is missing out some requirements, we have to go back. So as you see, between each of the activities, we have arrows back and forth. So we make the domain understanding, then collect the requirements. If we miss some requirements, we go back to the previous step. If we are happy with our requirements, we do the classification. And while classifying the requirements, if we find any problem, we go back to the collection again. Once we are done with the classification of the requirements, we do the conflict resolution, because there might be conflicts among the requirements, or there might be conflicts among the stakeholders. So if there are such conflicts, we go back to previous steps And if we resolve all the conflicts, we basically go for the prioritization, because now we have a stable sets of requirements with no conflicts, and we want to prioritize which requirements will be delivered. So after the prioritization, now we are going for the requirements checking or recurrence validation. And if we find any problems in the validation phase or checking phase, that means there was problem in our understanding or in our requirements collection or in classification or other steps. So we have basically go back again. But once we validate our requirements or check our requirements, we do the requirements specification. So this requirements specification should combine both the graphical modeling and mathematical notations with the natural language or high level description of the requirements. But again, if we find difficulties here, we have to go back again to the domain understanding and refine our requirements. But once we are done with our specification, that will produce basically this requirements document. So there is a very well defined process for requirements analysis and negotiation. And this can be viewed also in a spiral view that I will come back later. But the objective of requirements analysis and negotiation is to define a consistent and clearly written requirements, and also to have a set of requirements where everybody agreed. So we have to make sure basically all the stakeholders are happy with the sets of requirements. And once we are done with the requirements analysis and negotiation, we will potentially or for sure find out some problems. And these are the actions for each of the problems types. So if we have a missing requirements from any of the stakeholders, we add that missing requirements to our collection. If we find something about unrealistic requirements, we remove them definitely. If we have conflicting requirements, we try to remove the requirements that is less important or have less priority. If we have overlapping requirements, we try to modify those overlapping requirement and make sure that we have one single requirements. And if we have ambiguous requirements that is not clearly specified, we have to rewrite the requirements in a way that everybody understands it. So this is the spiral view I was talking about on requirements analysis and negotiation. And this requirements analysis and negotiation is also very time consuming and expensive in terms of resource, because you are gathering many people to discuss your requirements, and you are trying to find times that works for everyone and so on. So this is expensive and time consuming process wise. But in the analysis and negotiation spiral, as you can see, we have two different of lines. So the arrows denotes the artifacts or the outcome, and the lines without no arrows, those are activities. So we have three different outcome here. So the draft statements of requirements, that's the first outcome. Then the requirements problems that are based on this draft. So based on this draft, we identify the problems, and then based on these requirements problems, while we solve them or resolve them, we have this final requirements document. So again, we also have three different phases for requirements engineering process: requirements elicitation, requirements analysis, and requirements negotiation. So we start from this point, and then after the initial requirements elicitation, we have our first draft here. And after this first draft, we analyze our requirements and find out the problems in this point. And then we negotiate with the stakeholders and have the first draft of requirements document. And we continue in this way. But the interesting points are here, these three critical points, because these are the early phases of for requirements and also for requirements document. So we expect that these critical points will have some or maybe lots of problems with the requirements. And the more further away we go from the center, the more less problem we expect. So let's say we want to finish here. So this point, and this point, we have the more stable requirements and requirements document. But how we can do the requirements analysis, that can be another question. And there is a systematic way of requirements document. And the systematic way is you have these 1, 2, 3, 6, 8 questions that you need to ask for each of the requirements. And if you find yes or no based on what you are looking for, based on your judgment, you either accept or reject a requirements or modify a requirements. So the first one is premature design. So do your statement requirements include premature design or implementation information? Because in the early phase, you don't, or you might not have the idea on the design, right, or in the implementation. So your requirements should not include this premature design information. Is it a combined requirement? So if it's the case, you have to break down requirements into multiple requirements. Unnecessary requirements, is it a gold plating? Some requirements might not give you any functionalities or any non-functional goals. You might consider them removing them because they are just gold-plated requirements. Non-standard hardware. So if your requirements force you to go for let's say a server that is not very available, you might need to consider or reconsider that requirements again, because it will need some non-standard hardware to run on. Conformance with business goals, this is definitely most important. Once you have the business goals and then you define your requirements, if your business goals and requirements are conflicting, basically you have to redefine your requirements to be consistent with your goals. Then the ambiguity, it's all about how you write. It's clear and consistent. Realism, so if your requirements are not realistic, you have to remove them and you have to make them realistic. And also the testability, so is your requirements stable? As a tester, I will also read the requirements document, and if I find that this requirement, for this requirement, I cannot write a good test case, that means your requirements have a problem and you need to redefine your requirements. But of course, you cannot go for unlimited or long list of questions, because if you have, let's say, 50 requirements and you are asking these 8 questions, you already have 400 questions for your requirements. So don't go for a long list of questions, rather try to make it short or few questions. Requirements validation, so we are getting closer. Yeah, I have time also. So requirements validation, so we identified requirements in the elicitation phase, we analyzed, we negotiated, we solved some of the problems based on either if it's a missing requirement problem, if it's a testing problem, or it's a specification problem, and so on. But those were based on the requirements that are expressed in natural language. But now we are going to requirements validation that are not based on natural language, that are more mature requirements, I would say. So the goal of the requirements validation is to identify the problems or check for the problems and do it systematically with a group of people. So I will come to that part. What do we mean by group of people? So those group of people, basically the stakeholders, the requirements engineers, developers, and so on. And these are some of the common requirement problems. So lack of conformance to the standards, ambiguity, conflicting information, and so on, that we already discussed. And these problems must be solved before you generate your final requirements document, because if you already write your final requirements document with this problem, there is a very high possibility that your product will also be developed with this problem. So your end users or customers might reject your products. So this is the formal specification I already mentioned. I will not go into detail, but benefit of requirements validation or inspection is that it's a cost-effective way of discovering problems, because you still did not develop your product, and this is the last step, like requirements validation, to check or to ensure that your requirements are written well and clearly. So if you do these reviews or do this validation at this stage before developing your solution, it saves a lot of money and time for you. And also, if you do it in a group with the stakeholders, uh, usually that meeting should not be happen to blame who made this mistake or who wrote this, rather than trying to be neutral and solve any problems that is identified. And these requirements inspection meetings, or as part of the requirements validation, it should be conducted or chaired by someone who was not involved in your requirements definition or in your requirements elicitation. Because if you are part of already this process, you could be biased towards whatever requirements you expressed or whatever requirements you wrote. So it should be by someone, let's say, who did not look at the requirements document in earlier. And also, in this inspection meeting, someone should represent or present in a presentation style each of the requirements to the audience or to the stakeholders, and they can discuss the problems more formally. So this inspection should be done by a multidisciplinary teams. So we obviously know that stakeholders are multidisciplinary community. So people come from different backgrounds, different education, different skills, and naturally our inspection team or review team will be built using a multidisciplinary body. And it can be end users, it can be customers or their representatives, domain experts, requirements engineers, and so on. Basically, all the stakeholders. And if you have these multidisciplinary teams, they have different knowledge, skills, background, and so on. It brings a different viewpoints also. And but how do we do the validation? We already showed a checklist for requirements analysis. Now we have a checklist also for requirements validation. I will come to this, I think, in the next slide. But having this checklist is also useful for new developers or managers. Let's say when the new developers is coming in, if they go through this requirements document, it's easy to understand. It's even if they are part of the requirements inspection team, they can take process in the validation based on these questions and so on. But also for the managers who do not have technical knowledge and technical skills, including the end users, this validation checklist is also useful for them to validate the requirements even without any prior knowledge. So the checklist is look like this. It's similar to the previous checklist for requirements analysis, but it has also different sets of questions. And the first one is about the completeness. Second is about the consistency. Again, it's also understandability of the requirements, ambiguity, structuredness of the requirements document or the requirements, traceability, and conformance to standards. But at this point, I might ask also these interesting questions. So we have seen this checklist for requirements validation. We also saw another checklist for requirements analysis, right? Yes. So what is the difference of these two checklists? One is being used for requirements analysis, and one is used that we saw now is for requirements validation. Anybody is welcome to join in or give any input. Or probably I am not clear about the checklist. What do you think? What is the difference between these two checklists, or what they are doing in terms of checklist, or using this checklist, or what role they are playing in analyzing and validating requirements? So I'm trying to formulate different ways. Any idea? The answer is very simple. I just wanted to know that if you, or whether you could pick the idea. What's the difference between requirements analysis and requirements validation? No clue? I see all the happy faces, but the difference is basically the requirements analysis checklist. They consider individual requirements. So I'm basically analyzing individual requirements based on my checklist. But requirements validation checklist, they also look for relationship with other requirements. So they are not validated standalone for each of the requirements. Rather, if you need to consider the relationship with other requirements, you have to consider in this phase. So did I make it clear? And I will show you why. Because now we are talking about traceability that we did not talk about during the requirements analysis phase, and we are coming to that point. So we also talked about in our first spiral view about requirements validation, and it had 3 steps, right? One was the feasibility study, the second was the prototyping, and the third one was reviews. So now we are in the prototyping phase, and prototyping is kind of, you develop a simple version of your software, or if you don't, draw with pen and paper and show with to your customer. The goal here is to improve the requirements document, or to identify missing requirements, or even improve your requirements specification. This is all the things I said. But also, if you are developing a simple system, and let's say you did test with the users, but delivering the actual system or the real product is taking time, or you missed the deadline, what you can do, you can also use this prototype as a stopgap system. So maybe an intermediary solution. So one of the most common prototyping approach is paper prototyping, and it's also very cheap. or basically the cheapest, because in this manner you don't basically develop anything. You simply draw with a pen and paper and show the interface or the product ideas to the users and end users, and you go or walk through each of the interfaces with the end user and get their feedback to improve or identifying missing requirements. So let's say you have requirements like this. Joe wants to listen to a radio program on a radio device rather than on her laptop. She finds the available devices, choose one, and the radio program plays on the radio device. So this is a simple requirements, and this can be expressed to the end users in this way. Let's say you draw each interface of the application, like selecting the program, selecting the device, and so on, and then you show it to the user, and user give the feedback based on your drawings. You modify your requirements and so on. So this can be either a PC program, or this can be also a mobile program. So users should have all different versions or all different ways of developing the programs, or that is possible to develop the programs. And basically in this way you are giving users more opportunity to think, and you can come up with new requirements as well. Then another prototyping approach is Wizard of Oz, or Oz, W-O-Z in short, where you basically do an interactive presentation of the system, but again using the paper, pen and paper. So what you do, this is also a relative cheap, and I have an example here. So this is a, let me see if I can play it. So this is a diet app, and you have drawn user interfaces of various steps, and you are showing it to the user, and someone is playing the user role here, and someone is playing the engineer's role. So basically for each of the steps, you have to collect the input and output and pass it to the next step. So let me play it. So as you can see, you can log into this app either using your Gmail or Facebook. So this is the login interface you are showing to the user, and then once you log in, you have a different interface that you also drawn using pen and paper, where you have the main menu. You do the registration, and this is the registration or the registration paper, the interface. And then you have different diets. On the left you have you can have left menu. So let's say you wanted to drag the left menu, and the left menu shows up. So this is a new interface again you are showing to the user. On the left on the interface you might have different options that you might to choose. So you chose one option, and it shows what are the menu or diet you should have, and also you can go back. So what happens if you go back to the main menu, and so on. Yeah, now you went back to the previous menu. You can also do some visualization. So this is a very good way of doing prototyping your product, and user will follow you along the interactions, and they might give you new feedback, and even you might come up with new requirements. This is a little bit harder or difficult way, I'd say, from the previous approach, but this is more effective also. Okay, I'm going to the next slide because it's a long video. But now we are in the requirements validation phase, and we obviously might find some problems during our recurrence validation, And if you remember, we also found problems in the requirements analysis phase, and we had different action plan. And similarly, we have some action plan also for the problems that we find out after recurrence validation. So the first one is about the clarification. So we have to basically rewrite the requirements. Then the missing information. We might miss some information, and we have to go back to the stakeholders to find out missing information. Requirements conflicts. So we have to negotiate what should we do with these conflicting requirements with the stakeholders, and also the unrealistic requirements. So either we delete or modify them to be realistic. So these are the problems that we might find after our requirements validation. But then the requirements management, this is the last part, and I think I will take maybe maximum 15 minutes more to make it 90 minutes. So we talked about requirements elicitation, requirements analysis, requirements negotiation, and also validation. But all these steps are talking about the requirements before the development. But requirements management is about handling requirements after the development, or once you started your development. And this is about change. So requirements change, or they can change anytime. And if you have a good requirements management process, handling those changes will be efficient, and it will take less time and budget and so on. And there is a survey done on 4,000 European companies, software development companies, and that survey find out that this requirements management is the key problem areas for both the customers and also the companies. So we only think about requirements before we develop the software, but then we forget about the requirements and don't care much about the requirements when the software is being delivered. So the requirements management basically concerns these three things. Of course, managing the changes, and then managing the relationship among the requirements, and managing the dependencies among the requirements, document, and also other documents that are produced as part of the software development. So maintaining traceability, this is also important for requirements management, because as I mentioned, for software validation, you had number of checklists, and traceability is one of the aspect for software validation, asking does your requirement is traceable or not. So traceability information gives you who proposed these requirements, why proposed these requirements, if these requirements related to other requirements, and so on. And if you have this information in your requirements document, that means you have a good requirements document, and your requirements are well traceable. The first step to trace your requirements, obviously, to identify the requirements well. And if you want to identify your requirements well, you need to have a good identifier or unique identifier for the requirements, right? There are very good ways or bad ways of identifying requirements. Unfortunately, we most of the time follow the bad ways, and I will show you here both the bad way and good way that we follow. Having a unique identifier has many benefits. Of course, one of them is making the references to the requirements. And if you have a database for requirements, you can use this identifier as a primary key. It's easy to version your requirements as your requirements change over time. If you name it properly, it will be easier to track different versions of requirements also. So this is the good bad way of requirements naming or identifying requirements. So let's say you have these 6 requirements in the second section of chapter 4. That means chapter 4 dot section 2 dot number 6 requirements. So this might look a very good way of naming, organized according to your sections or chapters and so on, but this is also a very bad way, in fact, in practice. Why? Because let's say you have another requirements in your chapter 4 section 3, and that section also had 6 requirements. So that will be like 3.2.6. So having these 2 requirements, 4.2.6 and 3.2.6, the readers or the developers might think that you have very 2 similar requirements, but actually they can be very 2 different requirements having very similar name, right? So that's the very bad practice of writing your requirements names or identifying your requirements. But then to solve this problem, the good way is to use the mnemonic form. So basically the mnemonic form is about taking the keyword or the main or most important keyword from your requirement and then make it a sequential. Like let's say you have a requirements about security, so you can simply say sec and then some numbers to order your requirements. But then once you have the good identification of the requirements, we were talking about traceability, but traceability can be among or between different things. So traceability can be requirements between requirements and source. So who defined these requirements and why? Traceability, so this is basically the why. So this is who. So traceability between requirements and rationale. So why these requirements were defined. And then traceability between requirements and requirements. So if there is a relationship or dependencies with other requirements, between requirements and architecture and requirements and design. So this is in your architecture where certain requirement is implemented or put into the design. So this is more at the component level. So which component implement your requirements, and then also requirements between the traceability between requirements and interface. So if you have a external interface, which requirements need this requirement interface and so on. So traceability information can be stored in multiple ways. So one of the simple way is to traceability table. So basically in this way, you have rows and columns for the requirements where you store each of the information. So let's say we can say that requirements 3 depends on requirements 1. Requirements 2 depend on requirements 3. Requirements 1 and 3 both depend on requirements 4. So in this way, we can store the information of traceability, but this is not generalized, right? This is simply says that R3 depends on R1, but it doesn't say what types of dependency it is. So to make it more generalizable, or sorry, more specific, we can replace this X by very specific terms, like requirements 3 helps to specify requirements R1. Requirements R2 constraints R3. So there is a constraint relationship between R2 and R3. So in this way, we can generalize specify the traceability or the relationship between the requirements more. But this approach has a problem, and the problem is if you have more number of requirements, your table basically grows significantly. So now you have 4 requirements and you have already 16 information to store. But if you have 50 requirements, your table will grow significantly. So this approach of using traceability table is not a good way to store your traceability information. Another way is the traceability list. So this is more simple and easy to handle way of storing information. And the previous table, as you can see, simply can be replaced by using this list. So R1 depends on R4, R2 depends on R3, R3 depends on R1 and R4, and so on. So this approach is useful for large sets of requirements, but the problem with this approach is that it's easy to go from this direction, but it's not easy to go for the from the reverse direction. So if we want to find out these groups of requirements is dependent on which requirement, we can find out easily that R3 depend on R1 and R4. But then, as you can see, R4 is involved in 2 cases. So it's not easy to extract this information based on this table if we want to go backwards. So that's I mentioned, but this approach is good for large sets of requirements. And based on this table, we can easily translate this into a graph. So let's say we said R1 depends on R4. That means R4 must be implemented before R1, right? So we can build a graph like this that says R1 must come before R1. Sorry, R4 must come before R1. And then we also said here, for example, R3 must come before R2 because R2 depends on R3. So in this way, if we can build a graph, we can also use this graph as a prioritization of the requirements. So let's say in this way now we have to implement R4 first, and then R1, then R3 and R2. So this table is also helping you not only storing the traceability but also prioritizing the requirements. And this table is only about dependency. We might have other dimensions, and if you have multiple dimensions, you need to have multiple tables, or you can extend this table with new dimensions. So that's the benefit of using this traceability list instead of a traceability table. Now, managing requirements is problematic or complex when you have large requirements or large sets of requirements. And if you use a database, that would be more easier to handle requirements management or to manage your requirements. And of course, benefit is that you can search or look for your requirements. You can generate this type of traceability tables and traceability list from this database. And you can also look for system information. Let's say you have requirements like user requirements and system requirements and so on. So based on the requirements, you can generate those kind of system requirements or system information also. But before defining or deciding on a database, you have to ask yourself these 5 questions. So how are your requirements expressed? Is it using notations or high-level language? How many requirements you have? So if it's a small number of requirements, you don't need a database. Are your requirements always developed or managed by the teams working at the same site? Because if if the developers are working on the same site, you might not need a distributed database. You just need a offline database, so you don't need an online database. Do you already use a database for software engineering support? So if you already have a database, you can simply add requirements to your new already existing database. You don't need to create a new database. What in-house database expertise do you have? So there are many different database types. So are you using a SQL database or NoSQL database or even a spreadsheet, simple spreadsheet? So it depends what type of expertise you have. But in general, relational database are mostly used, although some object-oriented database like let's say MongoDB, people use these days to store their requirements, because in that case you can not only store text, but you can also store objects or documents in the database. One of the good practice for managing your requirements is to identify volatile requirements, because we know that requirements change. Some requirements change more often than others. So try to identify the requirements that change very often. And if you identify volatile requirements, that is also helpful for your development, because you know which requirements will change very often, so you implement them more loosely coupled manner, and you can also plan your change better. And in your database, if you have a requirements database, you can create another column, let's say estimated volatility, where you can have different numbers from different types of requirements depending on their volatility or how frequent they change. And then there are different types of volatile requirements. So for example, mutable requirements, because of the changes in the environments where they run. So if your environment change, your requirements also change. Emergent requirements. So usually in the beginning, we might not have good requirements statements or collection of requirements. So they might have some missing information. So as we develop or progress, our requirements definition might be clearer, and we might change our mind and change the requirements as well. Consequential requirements, they are also volatile requirements, because sometimes you state your requirements based on the assumptions. So basically, if your assumptions change over time, your requirements will also change. And then also compatibility requirements, because if you have requirements that is based on the processes or based on third-party libraries or based on equipments, if they change, your requirements will also change. So handling changed requirements is also critical in the requirements management. And finally, try to record rejected requirements, because not all the requirements that we came out as part of our requirements elicitation process will be implemented. And in the beginning, as I mentioned, the difference between requirements engineering and difference between software requirements and business requirements is that software requirements might not be implemented. They are negotiable. So this is a good idea to store these requirements or those requirements that are rejected. And if you if you store them in your database, in the future, if there are similar requirements, let's say, that are already rejected or that are already in your database, you can compare them and find out that why that requirements was rejected, and thus these requirements should be also rejected because they are similar. And having rejected requirements is also important, because at this point one requirements might be rejected, but in future that my requirements might be required to implement also. So you basically don't lose the requirement, rather you keep it in your database. And you also can have a separate field also, or another column called status in your database, and where you can mark your requirements as accepted, under consideration, or rejected. And again, all these approaches or styles works well when you have large number of requirements in the project. And I think that's it. I'm on time, perhaps. Yeah. So if you have questions, you can ask, and I will be happy to answer and see if there is any questions on Slack. I see no questions on Slack, and maybe on YouTube. Oh, someone said we cannot see the slides. And then someone said, yes, they can see the slide. Okay, I don't know about YouTube, but it looks like it's working. So any questions? If not, then good luck and have a nice afternoon.